Welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry, unit 4 chemical bonding and molecular structure, and in this video we will discuss about shapes of molecules in which the central atom has one or more lone pairs according to VSEPR theory. In the previous video we have discussed if all electron pairs are bonded, then molecule has regular geometry, and these are the regular geometries: linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. And we have also discussed how can we find out the total number of electron pairs around the central atom. Once again, revise it. Total number of electron pairs around the central atom is equal to half of the number of valency electron in free atom plus number of monovalent surrounding atoms plus minus charge. Okay, if positive species is there, then we subtract the charge present on that positive ion, and if negative ion is there, then we add the charge, whatever the charge present on that negative ion. Okay, now let us see. If total number of electron pairs are 3, out of these 3, 2 are bonding pair and 1 is lone pair, then these electron pairs will arrange in trigonal planar. Okay, but due to the presence of this lone pair of electron, its shape becomes bent. For example, SO2 and O3. If total number of electron pairs are 4, 3 are bond pair and 1 is lone pair. These 4 electron pairs arranged in tetrahedral manner, but due to the presence of this lone pair of electron, its geometry is known as trigonal pyramidal. Example is NH3. If total number of electron pairs are 4, out of these 4, 2 are bond pair and 2 are lone pair. Arrangement of these 4 electron pair according is as per tetrahedral manner, and out of these 4, 2 are lone pair. That's why its geometry becomes bent. Okay, and example is H2. Once again, see how can we find out the total number of electron pairs. Like see this oxygen, you can say half of the number of valency electron in free oxygen atom, 6, plus monovalent surrounding atom, this 2, and this is equal to 4. Out of these 4 electron pairs, these 2 are bond pair and 2 are lone pair. Okay, 4 electron pairs arranged in tetrahedral manner, but due to the presence of these 2 lone pair of electrons, shape becomes bent. If total number of electron pairs are 5, out of 5, 4 are bond pair and 1 is lone pair. First of all, arrangement of electron pair is trigonal bipyramidal. Okay, now due to the presence of this one lone pair of electron, its geometry will distort it, and this geometry is not regular. How it will change? First of all, at what position this lone pair of electrons should be placed? According to VSEPR theory, repulsion should be minimum. These electron pairs arrange themselves to minimize the repulsion, and in this trigonal bipyramidal shape, once again see this 3 bonds are in a plane at 120 degree. Okay, and these bonds are known as equatorial bonds. One bond is above the plane and one is below the plane, and these bonds are known as axial bonds. And if lone pair of electron is placed at any one of the equatorial position, then repulsion is minimum. That's why this is the lone pair at equatorial position, and its shape becomes seesaw. Okay, this seesaw, I think you are familiar with this. Example is SF4. Total number of electron pairs are 5, 3 are bond pair, 2 are lone pair. Then these 5 electron pairs arrange in trigonal bipyramidal manner, and these 2 lone pair of electrons occupy equatorial position to minimize the repulsion, and that's why its shape becomes T like this. Okay, this T shape. Example is CLF3. Once again, see how can you find out the total number of electron pair? Half of the valence electron in free chlorine atom, 7, monovalent surrounding atom, this is 3, there is the no charge, Okay, that's why it is not necessary to add the charge. This is neutral and this is equal to 5. Total number of electron pairs are 5. Out of these 5, 3 are bond pair and 2 are lone pair. That's why its shape is T shape. If total number of electron pairs are 5, 2 are bond pair, 3 are lone pair. Then again, arrangement of these 5 electron pairs is according to trigonal bipyramidal. And out of these 5 electron pairs, 3 are lone pair. And these lone pair of electrons will arrange themselves at equatorial position to minimize the repulsion. That's why its shape is linear. Okay, this is linear. Example is XEF2. Again, see how can you find out the total number of electron pair. Half of the valence electron in xenon when it is free, 8. Monovalent surrounding atom, this 2. Okay, and no charge. That's why this is equal to 5. Out of 5, 2 are bond pair and remaining 3 are lone pair. These 3 lone pairs arrange themselves to keep the repulsion minimum at equatorial position. That's why the shape of XeF2 is linear. If total number of electron pairs are 6, out of 6, 5 are bond pair and 1 is lone pair. The arrangement of electron pairs, that is all lone pair as well as bond pair, are as octahedral. But there is a one lone pair, and that's why its geometry becomes square pyramid or square pyramidal. For example, BRF5. If total number of electron pairs are 6, out of 6, 4 are bond pair and 2 are lone pair, then these 6 electron pairs arrange octahedral, and due to the presence of these 2 lone pair of electrons, its shape becomes square planar. For example, XeF4. Now, effect of non-bonding electrons. Okay, according to VSEPR theory, electron pairs repel each other, and this repulsion is in this order. Lone pair repulsion is more compared to lone pair bond pair, and this is more compared to bond pair. Okay, now let us see what is the effect of these lone pair of electrons on bond angle. This is CH4. Okay, no lone pair of electrons are there. Geometry is tetrahedral and bond angle is 109.5 degree. In case of NH3, there is a one lone pair of electron. Okay, arrangement total number of electron pairs are 4, and these 4 electron pairs are arranged in tetrahedral manner, but due to the presence of this lone pair of electron, geometry becomes trigonal pyramidal. Okay, and there is the repulsion between this lone pair bond pair is more compared to bond pair. That's why bond angle is reduced to 107 degree. Now, in case of H2O, okay, again total number of electron pairs are 4. Out of these 4, 2 are bond pair and 2 are lone pair. These are the lone pair of electrons. And again, lone pair repulsion is more compared to lone pair bond pair and bond pair. That's why its shape becomes band shape and bond angle is further reduced to 104.5 degree. Okay. Since electrons in bond are attracted by 2 nuclei, they do not repel as much as lone pairs. Therefore, the bond angle decreases as the number of lone pairs increases. Now, let us see some specific examples like SO2. Okay. Now, in this case, total electron pairs are 5, bond pairs are 4, and lone pair is 1. Dear student, according to VSEPR theory, electron pairs of a multiple bond are treated as a single super pair. Actually, in this case, these 4 bond pairs are present in the form of double bonds. Okay, you can see this is 2 double bonds are there in SO2. One this and one this. That's why total bond pairs are 4. But each this double bond is considered as a single super pair. Okay, and there is one lone pair of electron. And now again, if we use our formula, that is half of the valence electrons in free sulfur atom 6 plus monovalent surrounding atom, no. Oxygen is a divalent, not monovalent. That's why this is 0. And this is neutral. That's why no charge. And this is equal to 3. Total number of electron pairs are 3. Out of these 3, 2 are bond pair. Okay. That's why these 3 electron pairs will arrange according to trigonal planar. And there is a one lone pair of electron. That's why its geometry is bend shape. Again, remember, don't be confused. This bond pair of electron, or we can say this bond, is considered as a single super pair. Okay, but actually this single super pair is consist of double bond. Okay. Now again, in this case, this lone pair bond pair repulsion is much more as compared to the bond pair repulsion. That's why this bond angle is reduced to 119.5 degree from 120 degree. Okay. One more example, SF4. Now in case of SF4, total number of electron pairs are 5, bond pairs are 4, lone pair is 1. Now question arises, what should be the position of this lone pair of electron? We already discussed. Once again, see, this is sulfur. 5 electron pairs are there. These 5 electron pairs may be arranged in this trigonal bipyramidal form. Okay, and out of these 5, these 3, these positions are known as equatorial positions. Okay, and these are the axial positions. And this bond angle is 120 degree. This is also 120 degree. This is also 120 degree. Okay, that is equatorial bonds are making 120 degree bond angle to each other. Now see, this is axial position. This is also the axial bond. Now if you see the bond between this axial position and this plane, this is 90 degree. Okay, and again remember, if bond angle is more than 100 degree, repulsive interactions are not significant. Okay, that's why if we place this lone pair of electron at equatorial position or at axial position, what is the repulsive interactions? Now see, in this lone pair is present at axial position, this one. Okay, so there are 3 lone pair bond pair repulsions at 90 degree. This pair of electron will feel the repulsion from these equatorial bonds, which are at 90 degree to this one. Okay, now in B, this one, the lone pair is in at equatorial position. This is the equatorial position, and there are 2 lone pair bond pair repulsion. This lone pair of electron will feel the repulsion from this one and this one, because these bond pair of electrons are at 90 degree to this one, but will not feel the repulsion from this one and this one, because these are at 120 degree. That's why in this structure repulsion is from 3 bond pairs, while in this repulsion is from 2 bond pairs. Where is the repulsion minimum? Definitely in the structure B. That's why the structure of SF4, this is distorted tetrahedron or a folded square or a seesaw. This is more common term for this type of structure. Okay. Now see one more example, CLF3. Now in CLF3, total electron pairs are 5, bond pairs are 3, lone pairs are 2. Now again, these 5 electron pairs will arrange in trigonal bipyramidal manner. Okay, now again, what should be the position of this lone pair? We already discussed the repulsion is minimum at equatorial position. That's why these 2 lone pair of electron occupy equatorial position, making the shape T shape like this. Okay, now in this structure you can see one lone pair is at equatorial position and one is axial position. Repulsion is more. That's why less stable. Now in this case, these 2 lone pair of electrons are at axial position. Again, more repulsion is there. That's why this is again least stable. Most stable structure is this one. That's why CLF3 has T shape. Okay, you can see in A, the lone pair are at equatorial position, so there are less lone pair bond pair repulsions as compared to others in which the lone pair are at axial position. So structure A is more stable and this is T shaped. Okay friends, thank you.